All right, so we have a triangle ABC, and we draw a circle with center P on AB. So let me just draw this. Yeah, so the hack to drawing with the mouse is to draw the circle first.
Oh yeah, I should mention, yeah, like the first 4 questions are now done. You notice they're worth 2, 2, 3, and 3, right? So that's that's 10 marks. I think 10 marks is pretty close to the average for this whole exam. Okay. So um yeah, and for like say year sevens and lower, the average is more like 6 marks.
Yeah, 10 marks
And
is
this is
higher
an
than the
average out of
average.
all the people who get invited for prizes and stuff.
10 marks is actually higher than the average. Okay, so we have a circle. Okay, we have A, B, C. Yeah, average was 9.7. Um, oh, sorry, I've misdrawn this, which actually makes it easier to draw. Cool. So we've got A, B, C. Center of the circle is P. And we have that these are tangent. CA and CB are tangent. And we're given the length CA is 70, BC is 50, CA, AB is 90. So we're asked to find 2 times AP. And the reason we're asked to find 2 times AP is because AP is obviously going to be a multiple of a half, like something and a half. All right, so let's just start drawing in some lines. We've got the radius. The radii, which we know are perpendicular to the tangents. What else do we know? We know that this distance here is equal to this distance here. So we can call these two x and x. What was next? Let's call these points of contact R and S. So CR and CS is with x. And so what I did was I dropped the perpendicular from C to AB. Let's drop it down. So now we also know that this is the radius of the circle, radius of the circle. We've got an, okay, so let's consider the triangles. Let's consider triangles BPR and triangle BPC. BPC. Well, in this, well, I mean, I've already written down this similar, but they're similar because they both share the angle at B, right? So angle B common, and then angle BP, no, so angle BRP equals angle BPC. So these are equiangular, right? Oh, no, whatever. And so from this, we have that note that AP is just 90 minus, or rather BP is just 90 minus AP, right? So we can, so from similar triangles, we have that this side on, which one do I want? Sorry, let me also label this as Q. So CQ, so these are both opposite to angle B, CQ and R is equal to BP, which is 90 minus AP. What is going on? Just let you guys sort that out in the chat. Okay, so CQ over R is the same as BP over 50. And we also have the triangles on this side. So we have triangle A, this is a mistake. This should be BQC, right? BQC. Okay, so now we look at the triangles APS and triangle AQC. It's also going to be equiangular, so angle A is common. Angle Q, so angle A common. Angle at AQC is equal to the angle at AQP is equal to 90. So this is equiangular again. And so from this triangle, we have CQ on R equals AP on 70, right? Oh, hello, Yasser.
Hello. Okay.
If you're speaking, I could barely hear you.
Hello.
Hello,
Okay.
that's better.
What is this question?
Yasu in the house.
Yasser in the
What is this
house.
question? AIMO
Yeah.
17. Okay. Do I still remember that question? I had to look at.
Oh, wow, you did it in this year.
Yeah, I did this question like in 2017.
Right. Interesting. Okay. So just going back to this, we have CQ and R in both expressions. So let's equate these two. So we have 90 minus AP on 50 equals AP on 70. And so we can solve this, right? 6,300. And it's probably better just to write it as 70 times 50. 70 times 90 is equal to 50 AP. So we have 70 times 90 equals 120 AP. So we divide both sides by 60 because we want 2 AP, right? So we have 2 AP, 2 AP, that's what I've been writing. Divided by 60, so this is, we divide the 30 into this one and the 2 into this one. 35 times 2, so it's equal to 70. So 2 AP is equal to 70. Can you please zoom out? Oh. Okay, so does everyone follow? What we did was, what I did was just chuck down this perpendicular. We have similar triangles, and then we just get these ratios. And then luckily we have the same ratio in both triangles, so we can just equate and get rid of these unknown variables. And as for the marks, you got 1 mark per diagram, and you'll always get, it seems for every solution in every geometry problem, you get 1 mark for a diagram. Next, you got 1 mark for each of these similarity things. Was it 1 mark for that, or it might have been, one second, let me. Question 5, right? Yeah. There's 1 mark for the diagram. Is this still a 3-mark question or a 4-mark question? It's a 4-mark question, all right? No, this is still 3 marks, yeah. So it's 1 mark for the question, 1 mark for the diagram, 1 mark for the answer. Sorry, 1 mark for the diagram, 1 mark for the similarity stuff, and 1 mark for the answer. And as for statistics, this question was done significantly worse than the previous questions. So out of like 2,500, about 254 students. Sorry, it's not about, exactly 254 students got this question right.
So there's only like 10%.
Yeah.
So definitely, wait, it feels like it should be like a HD cutoff.
Yeah, pretty much.
But probably like a prize cutoff even. Kind of question. Actually, not, maybe not prize cutoff. Maybe HD or D cutoff. So
Price cutoff seems to be 2%. Around 2%. Yeah, wait. Oh, thank God, I was recording. But I forgot to record. Should I do question 6 now, or do you want to do your talk? Yes. Michael, Yasser, either of you?
The question
Wait,
six.
can someone send the whiteboard link?
Question
Oh, yeah.
6.
Wait, are there any more comments for this question? Did Yee have some comments? I thought she did this one too. Oh no? Yeah, so this one actually, like, you wouldn't be able to fake solve quite easily because of the numbers, right?
Mm-hmm.
You'd have to somehow, yeah, so circumvent the numbers.
I think I was planning to do question 6, and then we were going to ask you to do question 9. Yes, sir.
Oh yeah,
Yeah, so
that's what Michael said. Yeah.
so let me just okay, hopefully Anson got the whiteboard link. But anyway, so maybe I can introduce Yasser. I don't know if you guys all know Yasser.